All right, so let's talk about this triangle here. What these are perpendicular bisectors. And where they meet inside of a triangle, perpendicular bisector is, it bisects the side and it goes straight up 90 degrees from here. So what this finds is this point here where they all intersect, okay? This is called the circumcenter. Now what's cool about this point is that it's equal distance from every single vertex. Okay, that's what's special about it. All right, yeah, that's enough for that one. Next, the incenter. What's special about the incenter? The way you find it first is it's the angle bisectors. You do the angle bisectors of all the things and you end up with this. What's special about this dot? This dot is equal distance from every single side. Okay, so it's equal distance from here, and from here. All the sides are equal distance from each other. Now let's talk about the centroid. Okay, how do you find the centroid? You use medians. Median is you start in the corner and you bisect the side. Okay, you start in the corner, you bisect the side. You start in the corner and you bisect the side. Now you see this point where they meet, it cuts every line into a 2/3, 1/3 piece. So 1/3, 2/3, 2/3, 1/3. That's what's happening here. It's cut them into 2/3 and 1/3. Now, this one is altitude. The way you find the orthocenter is you find all of the altitudes. And where they meet tells you if a triangle is an acute triangle, an obtuse triangle, or a right triangle. Okay? Now, what's an altitude? An altitude is the height. So you would start at the top and go straight down. You see how it doesn't cut the side in half? It just goes straight down. Then you would turn the triangle and then do it again. Go straight down. And then you would turn the triangle and then go straight down. And where they meet will tell you if this is an acute triangle, a right triangle, or an obtuse triangle. An acute triangle ends up inside. A right triangle ends up in a corner. And then an obtuse triangle would end up somewhere on the outside. So you'd see that their lines wouldn't intersect anywhere in here, so you have to extend them out. And then all of a sudden you'd notice that all of them intersect somewhere outside of the triangle. Okay? Now the other thing we're going to talk about is this. How do we find the largest side only knowing the angles? Well, the larger the opening, the larger the side opposite of that opening. So the 80 degrees is the largest angle, which means BC is the largest side. Then 51 is the second largest angle, which means AC is the second largest side. Then 49 is the smallest, which means AB is the smallest. Okay? So this angle controls the opening. This angle controls the opening. The larger the angle, the wider it is, the longer the side is on the opposite of it. So the same thing is true with sides. The opposite angle of the largest side is the largest angle. So this is the largest side, which means A is the largest angle. Then 8.1 is the second largest side, so that means that B is the second largest angle. Then 8 is the smallest side, so opposite of that is the C, which is the smallest side. Now leads us to our rules for triangles. For triangles, if you add up any two sides of a triangle, it must be larger than the third side of the triangle. So you can check them all. 3 plus 5, is that larger than 7? Yep. 3 plus 7, is it larger than 5? Yep. Is 7 plus 5 larger than 3? Yep. This meets the requirements. You can make a triangle with these three lengths. Let's check this one. 10 plus 5, larger than 2? Yep. 10 plus 2, larger than 5? Yep. Is 2 plus 5 larger than 10? No. Which means you cannot use these lengths to make a triangle. Okay, it is impossible. If you stretch out 5 and 2 as skinny as it can be, it'll make a 7. And you have to have some kind of bend to make a triangle, so this cannot make a triangle. And that's pretty much it.